Alright, so let's take a look at part C of our problem number 1. We've been working with the same two functions in parts A, B, and C. And this time it's another division problem. However, instead of f over g, it's g over f. They could have called this function h or anything, f, g, and h are probably the most common letters that they use to define functions, in my opinion. This is just a name of a new function, and that name gives us a clue, an idea of how this function was created. It was created taking function g and dividing it by function f. So through substitution we can replace this g of x with x plus 1 over x minus 1, and for f through substitution we have this. So we saw in the previous problem that when you have a complex fraction, they expect us to simplify our answer, and that division is the same thing as multiplication by the reciprocal. So this numerator that is a fraction, why we just write it down, but we change the division to multiplication if we take the reciprocal of the divisor, which means just flipping it. When we multiply fractions together, it's pretty straightforward. You just simply multiply the numerators together and multiply the denominators together. You just go straight across, which is much easier than addition or subtraction, because that requires getting a common denominator. This just requires that we multiply them. So in the numerator, we just have x plus 1 times x squared minus 1. And in the denominator, we have x minus 1. So instead of, the two fractions, we have a single fraction. We want to continue to simplify this by factoring the numerator and recognizing that the numerator and denominator have a common factor. And x minus 1 divided by x minus 1 is just 1. And when we write x plus 1 times x plus 1, we typically use exponents and say it is x plus 1 squared. So they asked us to find the equation for this new function, g over f of x. And that's what we did. So here is our final answer. Hope that helps.